All right, so we are now on, I suppose this is day 3 here, of picking back up with Python. And so yesterday we had been talking a lot about functions and specifically passing of variables or arguments into functions, and whether when you modify something in a function, that change stays around in the variable outside of the function. So that's a lot of what we did yesterday. Now, I perhaps won't spend too much time on it, but it might be good for us to just talk a little bit about, well, what are functions and how are they structured? So in Python, you denote a function with this keyword here, def, stands for define. And then you have the function name here after the keyword. And then inside of the parentheses, this is called the argument list. And so arguments are positional. You cannot switch A and B here because the variables that you pass in have to be in the order that you expect them there. So right now, we are kind of expecting here for this sum A and B to be either an integer or a double or something. But let's say you might have a function that, like, oh, I don't know. Like, let's say you have a function that, what's a good thing? Well, let's say add. So you might have a function up here or a variable up here. It's a book list. And so we'll start it off as an empty list. And then you might have something that takes in a book title. And then it also takes in a number of pages. So if this were our function here, then if this were our function, then you cannot, we would call this, I'm not actually going to write it out, but the idea would be to add a title, a number of pages to this list here. Well, the point that I'm making is that you would have to call this something like, I'm not actually going to be accurate here. I'm just guessing. What is it? Let's call it 350 pages. Okay. You'd have to call it like this. You could not call it like 350 and Harry Potter. Now, you probably knew that already, but this means that the arguments in a function are positional. You cannot just rearrange the order however you want. The order that you pass variables when you call or invoke a function, if you're familiar with that terminology, has to match the order of the variables inside the definition of the function. Does that make sense?
Yeah, it does.
Okay, so this is hopefully is review. These are just the basics of functions. So again, we said define it with the initial keyword, you have the name of the function, you have the argument list in parentheses, and then in Python, you just use a colon, and then you indent the body of the function on the following lines. So that is function basics. Now, there are some other complexities that we're not going to get into. You can actually, I'm not even going to go there. I was going to say you can pass functions inside of other functions, like, but let's not talk about that. So we also will not talk about recursion at this point. If you've followed any sort of theoretical programming class, they will very likely make you do it. Now, the thing about recursion is that there's only a couple cases in the real world where it's actually the preferred approach. One of those is in traversing trees. Trees are a data type. And trees are kind of difficult to think about. So iteration, that is using loops, is the alternative to recursion, basically. But recursion is very difficult to think about most of the time. And so if you were to try to check code into a repository on a real world project and you used a recursive function, most people would probably reject your code and say, don't do that. And so for that reason, we're just not going to talk about it. But recursions are heavily involved in understanding how functions get called. And you remember last time when we were talking about the analogy of pancakes or trays on a stack, right?
Yeah.
Well, recursion deals a lot with that stack. And so if you've ever heard of a Stack Overflow, right? Like as in Stack Overflow, the website for questions and answers, well, that means that you're creating too many call stacks. You have something in infinite recursion, and it's creating a whole bunch of function calls without terminating any of them. And then you run out of memory, and then we call that a Stack Overflow error. So we're going to skip recursion. We're doing that intentionally just because best practice wise, most people do not use it in the real world. Like I said, there's a couple cases, trees in particular. Sometimes if you have a traversal function for a tree, or I don't know, trees in general tend to actually use recursion and some other stuff. But for the most part, you will not actually use recursion in production code because it's just too hard to understand. It's much simpler to do things with loops because they're more straightforward, easier to think about. Okay, so I think that's functions itself. Just recap. I'm not going to spend too much time. Make sure that you do understand the idea of passing by reference. We did say that Python actually technically does something called pass by object reference, but for now, just think of it as pass by reference. The variable, if it exists outside the function, you pass it inside the function. You actually do change that variable if you modify it. Now, if you assign it, if you make a variable of the same name and assign it to something, well, then you use the function variable inside of the function's local scope. But we argued that that's just a terrible idea in general because it's very confusing. And so if you're going to make a local variable, just don't call it the same thing as something outside of the function, right?
Yeah.
Okay, so that was yesterday. So functions in general, do you want me to say anything more on them, or do you think you got it?
I think I got it.
I guess one other thing I didn't do is that functions have a return type or a return value. Now, Python, as compared to other languages, doesn't force you to specify a return type. It doesn't force you to specify types on these things either. So if I were defining this function in like C# say, I would need to specify data types on everything like this. And so I would need to specify the type that the function returns, the types of the inputs, and then it can only act if you give it an input. It will still add the inputs, but in Python, you don't actually have to specify types on things. Now, this is kind of nice in some ways. It means that you don't have to write so much, and the interpreter that runs your code will be able to figure it out because it's smart. But on the other hand, it can get you into trouble sometimes if you're expecting your function to return one thing and then it returns something else. So I'm going to kind of harp on this, but it will be considered best code practice to always return things of the same data type in a function. And so you don't want to have one return path in the function return a string and one return path return an integer, because what happens if something calls that code and it's expecting a string, but then it gets an integer? See what I'm saying?
Yeah.
So generally best practice to still have your function only return one type, even if Python doesn't make you specify it. It's not a strongly typed language. The compiler itself won't check it because you don't compile Python code, you run it. However, still best practice to avoid returning things of more than one data type. Another thing very common for introductory programmers in Python, to end up doing something like this, they'll want to, well, I mean, it won't make any sense in that function. Like, they'll have a function that will end up returning, like, it will return a list. And like, let's say the first thing's the second thing's a string, the third thing's another list. They'll return a compound data type because they decide that they want to return more than one thing from the same function. You can do this in Python. Nothing is going to stop you because lists can contain whatever you want, data type wise, dictionaries as well. Nothing's going to stop you from doing this. It's still also just considered kind of bad practice because A, it's kind of confusing if you're returning multiple things from the function. And B, you can't do this in other languages that aren't dynamically typed like this. And so it just will look different than, like, if you were to want to like ever convert this code into another language, that happens sometimes. Projects will switch languages or whatever. You can't cross compile it because the code's too different. And like I said, actually the main reason, even aside from that, well, you say, well, I'm only going to do Python. Why can't I do this? The main reason is just because it's confusing. You want to try to keep functions as simple as possible, as broken down as possible. In programming, there's this word here called encapsulation, which means you're supposed to kind of box complexity as much as you can. So you'd have one function do one thing specifically. If you start writing functions that do 3 or 4 or 5 things, that's bad because it means that you haven't broken down the problem as effectively as you could. So you want each function to only do one thing. Is what I'm saying making sense?
Yes, it is. Isn't that the concept of What's the word for it? Well, I don't remember the technical term, but it has to do with, oh God, I don't remember. But it's the idea of keeping, well, keeping in, I think it's an object-oriented programming where the objects are really just one thing at a time. It's not abstraction. I don't know if it's not cohesion either. There's a word for it.
Mm.
For it. I don't remember.
Well, at any rate, the basic gist is that you want to keep things very structured inside the small boxes that they need to know about. And by the way, in terms of,
Separation of concerns, right?
Separation of concerns. Yeah, sure. I mean,
yeah.
I don't know if that's exactly the phrase you were thinking of, but yeah, that's a good way of putting it.
Yeah, yeah, that's the phrase I was thinking of.
Yeah. Now, I did another series kind of on why learn how to program in general. It's also up on the YouTube channel. Now, one of the things that I mentioned is kind of how it helps shape how you think. What we're talking about right now, this is exactly one of the ways in which programming actually can really help you organize certain other things in your life, activities. It makes you think in terms of algorithms and breaking down complicated problems into smaller problems and then tackling them one at a time. This actually isn't super unique to programming. Engineers do exactly the same thing. Specifically engineers who have to deal with big systems, you're never going to understand the whole system all at once. And so what you need to do is you need to break down your problem, split it into smaller parts, and each part only needs to worry about, the things relevant to it. That's exactly what functions do. And once we get to object-oriented programming, you'll see that that's what classes do as well. That's what objects do. They organize data and methods, things you can do with the data, kind of in a conceptual block. So it makes everything easier to think about, but each class only needs to know the things relevant for its class, not the things that you do with other things. So maybe that's a little bit hand wavy for the moment, but I'm just bringing this up because this is a really important part of quote unquote learning how to think like a programmer. You need to get used to the idea of I want to keep my functions as dumb as possible, and they should only do one thing. Because sometimes this is difficult. If you have a big event loop, if you have a big loop, like you're going through, I can give you an example from work. I've mentioned that we're importing stuff from an Excel file, right? Well, you might have the file open in memory. You have some boilerplate code to open the file, and then you go through all the rows in the file and you do stuff. Well, it might be kind of difficult to separate some of this logic out because you need to like open the file, convert it to a byte array. Might not mean anything to you, but you have to do that to use certain functions on it, and then go through row by row. And some of that you really can't split out into separate functions because it's all related. But the code to actually import a row, well, maybe you can split that onto a function. And maybe that row contains a bunch of columns. Maybe you can make a function for importing the value in each column because you probably want to validate the value in the column, right? You want to make sure that if this is a date, that it's actually formatted as a date and that it's a valid date. See what I'm saying? So you might split this problem down from, okay, I have to import the whole file to, okay, I have to import one row to, okay, I have to import one column in the row. You see what I'm saying? And breaking things down like that, what it will do is it will help you manage your complexity in your code. Because then at any given point in time, the only thing that you have to worry about is what is this thing right in front of me? What is it trying to do? Because if you get the logic right for opening a file and then looping through it and then trying to import each row, well, you don't actually have to worry about importing the row correctly. All you have to do is make sure that you're calling the function that will import the row correctly. And then you write the function to import the row. And for that one, you don't actually have to do each thing individually. You just have to make sure that you're calling all of the functions that import each column correctly. See what I'm saying? And so you break the system down from bigger problems into smaller problems into smaller problems. And what it does is it means a good rule of thumb is that when you have your code open in a text editor, a no function should ever take up more than a full screen. Now, that is a rule of thumb. We freely violate that all over the place. Specifically, if you have something that has a lot of cases, like if it's a big if, else, if, else, if, else, if, else. If the logic is not terribly complicated and you're just kind of multiplexing between options, you can break this rule. We do rather regularly, actually. But if you're doing something, if it's not just like a bunch of repetitive boilerplate kind of code, you really should try to keep your function smaller than a screen. Because if they get bigger than that, you're going to have a really hard time understanding it later. And so will anyone else who has to read your code.
Yeah.
So very, very crucial part of programming here. Went off on a little bit of a tangent, but definitely start thinking about how, whenever you're tackling a problem, how can I split this? Now, sometimes you don't want to get in the habit of making every function like only 2 lines long. Like there's a happy medium here between, every function only contains 1 statement and my function is so long that I have no idea what it's doing. You want to kind of hit the middle ground. Like I said, keeping functions within about a screen's height is usually a pretty good bet for my function is doing one thing and it's only going to do that thing. And I'm going to separate my concerns, like you said.
Yeah.
Okay,
Okay.
so that's functions. Now, before I did come up with some practice problems for us here, but before we do those, I decided to have our discussion of conditionals at this point. So the first set of practice problems that we're going to do are going to be about functions, but they're also going to contain conditionals. And the difference between these and the ones we'll do later is that right now, we're not going to focus on loops. We're not going to focus on repeating any code that we do. We're just going to focus on the logic and returning things from functions. So before I spend too much time talking, how much do you know about conditionals? Do I need to spend a lot of time on them, or do you feel like you got it already for the most part?
Yeah, I think I've got it, but use cases might help me understand a bit more.
Okay.
I think I get the concept.
So first thing to say is I actually had a thing here for switch statements. Now it looks like they're adding them in Python 3.1 or 3.10. Now you don't need to worry about this. Most languages have an alternative to if statements, which is like if you have a value that's not simply true or false, but you have many value options, many languages will implement what they call a switch statement. It has slightly different syntax, but it is basically the same thing as an if, else if, else if, else if, else. It's not any different than that, like in terms of what it compiles down into. It's just a different way of representing that concept. However, Python actually doesn't have it. Python does not have switch statements. So in Python, you have to use else if. Now in Python, I believe it's actually like, let's say we have 2 variables, A and B. And so we'll say A is equal to 5 and B is equal to 10. And what we want to do is check. So if A is less than B, or A is smaller, not bigger. Should get my logic right here. Okay, now if I have an else, what will the else case represent here?
A would be equal to B.
A would be equal to B, right?
Yes.
So we would print here that A and B. So if you understand this example, you basically understand what conditionals do, right? So whatever is inside the body of the conditional case that you hit will be executed if the condition is true. But only one thing, this is the really, really important part, only one thing can execute. So these things are mutually exclusive. If A is less than B, only this runs. This doesn't run and this doesn't run. Does that make sense?
Yes, it does.
Okay, and then else if this is true, only this runs, and then this doesn't run and this doesn't run. And otherwise, that's how it works. So as long as you understand that, you basically have conditionals. I don't want to overly belabor the point. I don't think conditionals are as complicated as many other things. Now, of course, something important to note for conditionals is that, you may do some comparisons like this, but what's more common for conditionals, at least in what we do, if we're doing validation, you might do something like var dot is, I don't know, like is positive. You would check something like that, or you would check if your variable like contains, some value, or what else? Do you see what I'm saying? Like very commonly, what you will have inside of a conditional is a function call that will return a Boolean. And in fact, you might have it you know, I got so used to C#, you see, or you might do something else, right? And so you'll commonly have ands and ors and things. Now, one thing that is kind of a good note here is if you have a whole bunch of stuff. So if you are trying to say like, let's say you have like 5 things you want to check in a conditional, it might actually be better practice. It'll be more readable code wise if rather than putting things like if A is less than B, and I'm trying to come up with a good example off the top of my head. No, let's say that we have a string and we want to check the following things. So we would say starts with vowel. That's one thing that we're going to check. Capitalized in Python. Yeah. Okay. And then we wanted to start with, or not start with, we wanted to check what are other things we can do for strings? Say we want to check if it has at least 3 of the letter O. Okay. Well, to do this, you could write something where you actually to do this right here, you will have to make a function call or do some sort of other thing, right? However, the most reasonable way to, or sorry, not the most reasonable, the most readable way to make your code, like let's say we want all of these things to be true, then we would have to use logical and inside of the conditional. But very commonly, this is actually something that I'm kind of a stickler about when I peer review the code of people on my team, is we have to go back and we have to read what we write eventually. And so I much prefer, and in fact, I don't know if Python lets you do it. It might let you put things on different lines like this. And this is usually considered more readable so that it doesn't just all trail off one huge line. This is much more helpful. Like if this starts with a vowel and has length less than 10, it contains at least 3 O's, then we're going to do whatever we want. I mean, it's completely arbitrary. I was just making stuff up here. But the point is, you make a Boolean variable for each of the conditions you want to check. And then you just, the only thing that is inside of the condition of the if statement, what's between the parentheses, the only thing that will be there is ands and ors. And what you'll be doing is you'll be doing Boolean logic on a whole bunch of these variables here. And maybe this isn't so great. I mean, what I'm arguing against is having a check, having a function call here that's hard to understand, or even more specifically, a lambda function or something that where you're doing something inside of this, because then it just gets really hard to read. So with conditionals, usually recommend that you make Boolean variables. Now, you don't always have to do this. Like what would be a waste? What would be a complete waste is if you have something like, I'm going to say, we do something like this. Okay. Now, of course, A and B don't exist, so it's yelling at me. But if I were to do this, this is kind of silly because 100% what you should do in this case, since it's just one thing and you're not going to and or it, is you should just do it directly. You don't need an extra variable there.
Yeah.
Does that make sense? Does the difference in what I'm talking about make sense here? Where if you have ands and ors and stuff for readability and to help you track what it is, what's the logic that you're doing in the conditional here, it's helpful to actually split things out into variables so that you can see the ands and the ors and the nots and things like that. However, if you just have something that's simple and it's not a composite, it's not a composite Boolean value, you can just put it straight in the conditional.
So that's setting the conditions to well, I don't want to say Booleans, more like,
okay, this would never be just this. In fact, you would be like, what you would do is you make a function call like that, right? And then down here we'd have like, we'd have this, which, you know, would right. Do you see what I'm saying? Like This is how this would actually be set up, but
okay. Okay.
Yeah.
So the conditional would just be evaluating. Well, it doesn't evaluate the whether it's true or false. What it just checks is, in this case, when you have so many statements to check, or so many conditions to check, what it does is say if all of the conditions meets the, how do I put it now? The function you've written is supposed to return the Boolean, correct?
Do you want to actually watch me do this? I can do this. It might involve loops and stuff, but none of these things are hard to check here. So if you want me to actually flesh out the example, I can. Would that be useful, do you think?
Do that. I think I get the idea, but I want to be sure.
Okay. So let's say we'll call our variable myString, and I don't know, what's a string that has at least 3 O's? I don't know why I'm having such a hard time. What's something that has at least 3 O's in it? Like book has 2 O's.
Okay.
A bookworm. There. That has 3 O's, right? Okay.
Yes.
Okay. So the first thing we want to do is, does this thing start with a vowel? So there's two ways you could check this. You could check if it starts with a vowel, or you could check if it starts with a consonant. Now, which way do you think is easier?
I think it's easier to check whether it starts with a vowel.
And why would that be?
There are fewer vowels, right?
Exactly, right? And so there's a smarter way to do this, and then there's a less good way to do this. And it will certainly work. The code will work if you check if it's a consonant, but suddenly you have to check a whole bunch more things, right? So it's a little bit less efficient. So here what we would do is probably we would say, okay, so what we want to do is the first thing we should do is get the first letter, right? So the first letter, we're going to do myString, and then we're going to get the first letter of it like that. Does that make sense?
Yes.
Okay. Now, let's see how Python handles the idea of membership or contains. So if I want to say how to check if a value is in a list. Python. Okay. So you see what I typed into Google? How to check if a value is in a list. Now, what we want to do is we want to check if our first letter here that we're doing, we want to check if that's in the list of vowels, right?
Yes.
Okay. So we're going to click on the link and scroll down until we see code. And for I in test list, so this is one way to do it. Now, so multiple different ways to do it. Let's do it the more manual way. So what we'll do is we'll iterate through the things in the list. So next what we'll do is we'll make a variable called vowel list. And so the vowels in English are going to be A, E, I, O, U, and sometimes Y, but we're not going to say Y. And so then what we want to do is we want to check to see if the first letter in the string is any of these. And so what we can do, autocomplete? No, it's not going to autocomplete. So we're going to go through each of the things in vowel list, and then we're going to say if the first, now I know we're using loops, which we haven't gotten to yet, but bear with me here, because you said you wanted this fleshed out. So if the first letter is equal to the vowel, do I need to explain what I've done here? Or you want me to give you a second to look at it?
Yeah, let me run through it and see if I get it, right? So you define a function that takes in the variable my string, and then the first letter is you set the variable first letter to be the first element in the list bookworm. Is that the right way to put it? But the string is
this is not a list. This is actually a
string.
string.
Yeah, it's a string, right? But it's treating that statement appears to be treating it like it's a list, right?
So you can index. This is called indexing, right?
Okay. So
lists
it indexes the strings.
Yes, you can use indexes on strings to get the characters in different positions in the string. So indexing is not unique to lists. You can index into dictionaries as well with keys. So indexing basically means I want to grab a specific value in whatever it is. Now you cannot index into like an integer. Integers have no indices.
Yes.
But you can.
But you can do it with strings. Yeah. Okay. So then you create a list called the vowel list, where all the vowels are listed out, and then set up a loop that checks to see whether the first letter, okay, to see whether there's a vowel in that first letter, or if the first letter is a vowel. And if it is a vowel, then the function returns true. But the return false statement, is that to say, if it isn't there, return false? Is that it?
So here's how this works in the flow of execution logic. So these two statements are executed before we check anything, right? So the very first thing we do is we grab the first letter from the string, and then we define this list here, right? Right. So far, what we have in memory in this function scope is we have a variable called first letter that will here, given this input string, this will contain the letter B. And then we will have a list of vowels, A, E, I, O, and U, that will be a list in our function scope called vowel list. Does that make sense so far?
Yes, yes.
So now we are going to go and we are going to trace this. This is called tracing. In programming classes, they make you do this on paper. It's very useful. So in fact, I will sneak preview. I'll show you what this looks like in the debugger, okay? So I am going to put a breakpoint here, and I'll explain what that means in just a second. And we're going to go ahead and we're going to run this. Well, okay. Say we're going to run that. I need to comment out my in progress functions there. Let's try again. Hopefully I didn't make any silly mistakes. Oh, I know why. It's because I'm not calling it, right? So you see, I defined this function, but right now I'm not actually calling it with my string. So after we define it, what we want to do is, well, you know what? We can actually grab this right here, and we can do this statement. So we're going to set this Boolean value equal to the return of this, right? Now we should actually be calling the function. I think it's probably because I named it the same thing. Oh, give me a second. I don't know exactly why. Oh, it's because I probably have to just run through that menu. That's probably why. There we go. Okay. So going in the debugger here, what a breakpoint does is it tells you the computer is going to run the code until it hits a breakpoint. Now, how you set a breakpoint, this is true in most all text editors you'll use, is that you click next to a line. See that, the blue circle? Right here, blue circle?
Yeah, I see it. I see it.
Okay, so what I did was I put a breakpoint on line 190. That's right here, this statement. So when the debugger, when you're running the code and you get to a breakpoint, it does not execute the line that the breakpoint is on. It stops right before executing this line. Okay, so at this point, you see the section over here is called variables. This is what we have available to us in our function scope. Remember what function scope is?
Yes, I do.
So it's the things available to us inside of this function. So we have my string right now, and it has value bookworm. And we have that because we called this function right here. We called this function with my string, which is set to bookworm up here. You tracking so far?
Yes, I am.
Okay, so the next thing we're going to do is we're going to press this arrow here that says step. Next step. The double arrow means you continue until you hit another breakpoint. Well, we don't have any other breakpoints, so we're going to step through this one line at a time. So the next thing that's going to happen is we're going to execute this line right here. So remember, we hit a breakpoint that's on this line. That means we stop execution before executing this line. So this has not been executed yet. But when we step, so we press the step button here, we're going to go ahead and we're actually going to execute one line at a time. So after we execute this line, what do you think should happen?
I expect to see a new variable that will match the first character in bookworm.
So if we were to see something pop up here in the variable section, what would be the name and what would be the value?
It would be first letter. And the variable, the value, I'm not sure if it will be B or my string, with 0 in brackets. I'm not really sure. But I assume that it should be B then, right?
That should be B, because this is not something that will be saved. This is what we're assigning. We're assigning this equal to whatever this thing right here returns.
Yeah, it represents. Yeah, so I would expect it to be B then.
Okay, so let's see if we're right. Looks right.
Yeah.
It makes sense. Why does that?
Yes, it does. It does.
Okay. Now, how about vowel list? What do you expect to see after we execute? So right now we're stopped on this line, right? We are on this line. That means that we're before it. We haven't executed yet. What do you think should show up over here in the variables section? Given that this is an assignment, what should show up once we step over this next line?
Yeah, I expect to see vowel underscore list and under the variables, then the value would be the list of vowels A, E, I, O, U.
And it will actually show up as a list here. So this one actually will show up like this because we're not going to substitute this value with anything else. This actually is the value. So when we step over it, you'll see that we have the list here, A, E, I, O, U, right? Exactly as we expected. We good so far?
Yes.
Okay, now we're going to step through the loop. Now this is where debugging gets a little bit more complicated because you have to understand what is happening when you switch from thing to thing in the loop. So this is called a for each loop. We're going through each of the values in this list here. So what is vowel list? Vowel list is A, E, I, O, and U. And so when we say for vowel in vowel list, what we're going to do is we're going to get each one of these values sequentially as we go through the list. So the very first time through the loop, what will the value be? This does go in order, by the way.
Yes, the value will be A.
Okay, so when we step into this loop, so we're executing the loop for the first time, what should show up over here in variables?
In variables, vowel. Yes, vowel, and the value will be A.
Okay, let's check and see if we're right. We're going to step. We have vowel A. Good job. Okay, so now, are we going to go inside of this conditional or are we going to skip it because the condition is false?
We're going to skip it. Like we'll check and see that it's false. So we'll move on.
And that's false because first letter is B here and vowel right now is A and B is not equal to A. So we're going to skip this, right? And so what will happen when I press next here? So you said we skip it, so we're not going to go to this line, but what's going to happen next?
Yeah, so it's going to set vowel equal to E.
Okay, right, exactly. So
we're
gonna go next, and then we're gonna go back to the top of the loop. And so actually, when you're debugging, you are actually correct. So if we go twice, now it says vowel to E, but it's gonna go back to the top of the loop because we finished execution of that cycle in the loop, right? And then it's going to set the next vowel in the list to be E. And actually, the same process is going to repeat here for all the vowels because you see, well, val is equal to E, B is not equal to E. So we're going to skip the condition again. We step, okay, now we're on I. I is also not equal to B. And so we're going to keep going. So now we're on O. O is not equal to B. So we skip it again. And now we're on U. U is not equal to B. So we skip it again. Okay, so now after I press next, we're going to skip this. We're going to go up to the top of the loop one more time. At least I believe we will. And then it'll say, okay, I don't have anything left. And then we'll step on to the next line. So we'll see if it does that. Yep, it's going to go here. And see, we're at the end of the list. And now it's going to say, aha, I don't have anything anymore. So now we're going to be done with this block of the code. It's what's called a code block, the loop. And we're going to step on to the next line. Okay, so now we've stepped onto the next line. And we've decided that this first letter that we assigned to B up here, we got that first letter from the string. We've decided that it doesn't match any of the vowels here. And therefore, in the logic of how we've written our function, because it doesn't match any vowels, that means that start with vowel, the return value of this function should be false, right? And that's why we just have a return false here at the end, because if it were matching any of the values, we would have returned true in this loop here.
Yes.
Does that make sense?
So yes, it does.
When we step over this, we will say we returned. And well, if we step over this, we should see that now, I have no idea where we are. We have starts with vowel boolean. That was the return value from right here.
Yes.
It's false.
Yes.
So everything we just did makes sense.
Yes, it makes perfect sense now.
All right, so before we move on to the next function, just want to talk again about how important what we just did over here in the debugger is. If ever you write code and you're not sure what's happening, you can always just step through it, just as we've just done. Step by step, line by line, you can make sure that you understand exactly what the code is doing at all times. And this is absolutely critical for making sure that you understand what's going on properly. So if you're ever confused, if you ever wonder, I'm really not sure what this is doing, what value does this thing have at which point in time, then go ahead and set a breakpoint and step through it, because that is the best way for you to understand what's happening and make sure that you get your feet beneath you. And you may not be taking this as a programming class, but believe me, in college, you want to know what very popular test questions for us were? They would give us a function and they'd give us a starting value and they'd say, what happens? Line by line, give us the value at every point in time. And to correctly answer that question, you actually have to understand exactly what's going on at every point in time, right? And
yes.
So it's kind of a mean question because you have so many things that you have to write down, right? But it shows that you really do understand what the code's doing. So this is why the debugger is so important. And this is why you should make it your best friend, because whenever you're running code, doesn't matter what code, doesn't matter what programming language, if you know how to set a breakpoint and step through it, you will be able to understand what the code is doing. Doesn't matter how complicated it gets. It always, always, always executes one line at a time, because that's how computers work. So hopefully this one makes sense. And with this out of the way, AKA debugger is our best friend, and you better become best friends with it because you will need to use it all the time, anytime something goes wrong. Well, let's go ahead and let's write, oops. So I'm in read-only mode here because I'm on the debugger page. Well, let's go back here and let's stop our application. And now we can go ahead and edit so that we write the next function here. Okay, so the next function is going to return a Boolean if the thing has less than 10 letters in the string. So one of the things we can do is let's type in here to Google. Let's say, how do I get the length of a string in Python? Right? So to calculate the length of a string in Python, you can use the built-in length method. So this one will actually just be a one-liner. Do you want to tell me? So given that we get the length of a string by wrapping it in this function call here, that is, we have, this gets us the string length. What should this function return then?
Okay. Return true.
Should I just return true? Doesn't it depend on what the value of my string is?
Oh yeah. Yeah, that's true. I'm sorry. That's true. If 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 it has a length less than 10, okay, should return
Okay, so you're saying
false. Yeah.
if it has a length less than 10, that's what you just said, it
Yes.
should what?
Return true.
True. And then what comes next?
Else return false.
Else. Okay, so this will actually work. What we have right here will actually work, but let me see if you can spot it. There's actually an easier way. You don't have to even write this much. There's an easier way to write this function.
Okay. Okay. Just let me think a little.
So the trick is, do we know whether this is true or false when we plug it into the conditional? So if this thing is true, we're going to return true. And if this thing is false, we're going to return false, right?
Yes, yes.
Okay. So this thing has a truth value. Do you agree with that?
Yes, it does.
What happens if we just return this? Will that work?
If we, yeah, it should.
Right. So here's the trick. If we know that if this is true, we're going to return true. And if that's false, we're going to return false. Well, then we can just return whatever this is, because this is either going to be true or false. Now, the reason why this is maybe a little bit confusing is because you say, but I don't know what the value of this is, right? But the thing is, the program will, before it returns something, the order is confusing here. It will calculate this value before it returns anything. So this thing will evaluate to either true or false. And then no matter what this evaluates to, it's going to return that value. So there's nothing actually wrong with this way. It's just, you know, in the real world, you don't want to write this just because it's 5 lines of or 4 lines of code or whatever, when you can just get away with one like that.
Okay.
So now let's make our variable for this one. Okay, so we decided that our variable name here, we're going to stick boolean on the end. Otherwise, we're naming our variables the exact same things as our functions, which isn't good practice. Okay, so we are going to call this function with myString, which we decided was bookworm. So we would expect this to evaluate to what, true or false?
Yes.
If we input bookworm into this function, should it return true or false?
It will return. It will return true. True.
Will it? So 1, 2, 3, 4, 5, 6, 7, 8. Less than 10 booleans. Right. So 8 is less than 10. So this one will return true. Right?
Yes.
Okay. So last one. Our last function that we want to write is we want to check if the thing contains 3 O's or not. Okay. So to do this, let me see if you can get it without me actually just going ahead and jumping and writing it. So we're going to need to check every character in the string, right?
Yes.
So what's the easiest way to check every character in the string in terms of programming concepts?
For loops.
For a loop, right? Okay. So what should I write for the loop?
I would say for O in
O, or we want to check to see if something is in. We want to see if whatever we're checking is an O, right?
Yes.
So what is each thing in this string? Like, what is the word we'd use for it?
Characters.
A character. Yes. Character is good. Character or letter would both work here. Those would both be good variable names. For character, in what?
In string.
Is it just string? Is string defined in our scope? MyString,
yes, it is.
Right? Because MyString is the name of the variable in our scope here. Okay.
Yeah.
Now, what comes next?
if character is O, then what do we do now? Character is O. We increment some counter, right? Something like that.
So we probably want a variable like this, right?
Yes.
So we're going to start it at 0 because we haven't checked anything yet, right? And so if character is equal to O, we want to say that num O's does what?
We increase it by 1.
Okay. So we are going to reassign it here, except we're going to give it the value it had and add 1 to it, right?
Yes.
Okay. So that will get us done with our loop. And at the end of the loop, so we go through every character in the string. If the character is O, we add 1 to this number of O's. And then what should we return at the end of this function?
At the end of this function, if we will return number of O's. So,
but the return type here needs to be a boolean, right?
Okay, but wouldn't that require another if statement, essentially saying if number of O's is greater than or equal to 3, then return true?
So do you remember what we just did up here?
Yes. Oh, right. Right. So number of O's greater than or equal to 3.
Right. And that's it. We don't need to make that if statement. We don't need to make that if statement because this thing itself will evaluate to true or false. And if it's true, then we return true. And if it's false, return false.
Yes, that's awesome.
Yeah. You get used to this eventually. It kind of blows your mind the first several times you do it. Oh, I don't actually need to return true. The function will return true because this thing right here evaluates to true. Once you get that flip switch in your head, you'll stop trying to do that. Everyone, when they first start programming, wants to do that. You just don't need to. Okay, so does this make sense? So we start out, we're tracking the number of O's. We're going to go through every character in the string. And if the character is an O, we're going to increment the counter. And then at the end of this, we're going to return whether the number of O's that we counted was greater than or equal to 3, because that's what it means to contain at least 3 O's, right? So let's come and make our Boolean down here. Okay. Now this one, I won't talk so much, but I think we should step through it again, right? So we're going to be calling this function with my string, which we decided was bookworm, right? So I'm going to go to our debug pane here on our online IDE, and I'm going to set the breakpoint. So I've set the breakpoint on line 212 here, which is where we're declaring this variable. So I'm going to run it. And looks like I still had a breakpoint set there. So I'm going to remove the breakpoint here, and then I'm going to press next breakpoint. So that's going to keep executing until I hit another breakpoint, which is where we just are here on line 212. So now we're inside of our function, which means this variables thing here is showing us variables inside the function scope, right? So those are the global variables down here, the variables outside of our function. But right now we're interested in the ones inside the function. So right now, the only variable we have is my string because that's passed as an argument to the function, right? So breakpoint on 212 means we stopped execution before 212. So what happens when I press next?
Okay. When you press next, we have a new variable num O's, which is 0. The value will be 0.
Okay, num O's 0, right? Okay, so now we're going to go through the characters, which means that because our string is bookworm, the first iteration of this loop, we're going to be B, then O, O, K, W, O, R, M, right? Okay, so what do we expect to happen for this first time through? Will we hit the conditional when character is B?
No.
Okay, so character is B, right? And so we don't think that we should hit this, which means that we should jump back up to the top of the loop, right? We're going to skip this because B is not equal to O. Okay, so we jump back up. You see, we didn't execute this. Why? Because number of O's is still 0 here, right? We skipped it.
0, yes.
Okay, so how about this time? Now we decided the character is equal to O. So should we go inside this conditional this time? Okay, we do.
Yes,
you see, now we're on to 16. And what should happen after this line?
Okay. We'll check the next character.
So right now we're paused on line 216. What happens after we execute line 216?
It will jump back to 214.
But
yes, it will.
Does a variable change in value here? Like what does line 216 do? Is what I'm asking. Maybe I'm not asking
okay, right. It actually, yes, it changes in value. It adds 1. So it will now be
adds
1.
1 to number of O's. So when I press next, the characters, we're going to jump back to the top of the string. So we'll be done. We'll be done with the iteration for the second character, which is this first O here. Okay, but we will have incremented this. So number of O's should now be 1, right?
Yes.
And now we're at the top of the loop. We press next again. We're going to get the second O. Now we're on the second O here in Bookworm. And we're going to jump inside the conditional again. Why? Because characters O again. Okay, so we're going to jump. We're going to increment again. Now number of O should be 2. And now we're going to do character K. Okay, K is not equal to O. We're going to skip. Now we're on W. W is not equal to O. We're going to skip. Now we're back. Now we're on the O after the W in Bookworm. Now this is O, so we want to go inside again. Okay, we're going to increment. So now number of O's is 3. Now we're on R. We're going to skip because R is not equal to O. Now we're on M, and we're going to skip because M is not equal to O. So now when I step again, I'm going to be on the return because now we finished execution in our loop, right? We have no more characters to go through in the loop. So we're going to stop right here on 218 without executing 218. So on 218, you can see that number of O's here is 3, right? And so we expect this function to return true or false.
It will return true.
Should return true. So if we set a breakpoint down here, which is after this function gets executed, we should expect in our scope to have contains at least 3 O's Boolean to be true. We're going to continue. And see, contains at least 3 O's Boolean is true, right?
Yes.
Does our stepping make sense?
Yes, it makes perfect sense.
Okay, good. Like I said, just get in the habit of if you ever aren't sure about something, you can go and debug it. That is the pattern that you should get because that is very much how you will learn when you're programming. Okay, so now we have our 3 functions now with our 3 return values. And so now let's go ahead and we'll actually do this if that we now have commented out, right? In fact, I renamed all of these to have Boolean on the end. So okay. So if this, let's print value success. How about that? Okay. So right now we are going to, let's print completely arbitrary example here, but failure. Oops.
Parenthesis.
Okay, so right now we're going to expect failure because this word does not start with a vowel. Okay, so failure, right? Now, if we delete the B up here, what should happen now? It's not a real word, but per our criteria, should that pass?
Yes.
Because here, start with vowel, it does start with an O, right?
Yes.
And O is in our list of vowels. So this, when we run this, should return success, right? Does that make sense?
Yes. Yes, it does.
Okay, so to the main point that I was doing before, right? To the main point that I was doing before, this, if we had named our variable something or our function something different here. So what we're saying is if it starts with a vowel and it has length less than 10 and it contains at least 3 O's, we're going to do this. That's pretty readable, right? Because we immediately see exactly what this is. Now, if you name your functions, well, technically, rather than using this Boolean, we could actually replace that with that. Do you see?
Yes.
Starts with, why doesn't it like that? Sorry, perhaps I'm being really dumb. Oh, start with val. Okay, so that's the typo here. This really probably should be starts with val. You see, do you see what the problem is?
Yes, yes,
You
yes.
see what the problem is? The function is named start with val. It really should be starts with val. So that's why I was getting this here. See, now it's fine. So this is what it looks like if we don't do it with a Boolean. In our particularly contrived example, there's really not too much different. Like I said, if you name your functions well, it should be still pretty obvious what's happening. But you know, what happens if it gets more complicated, right? The initial point that sparked all of this before we went and practiced here was that we wanted to show that it's easy in conditionals. If you just use the Boolean variables to track things, then it makes the conditional really easy to read, right?
Yes, yes, yes.
Okay, well, we certainly did some examples here. We did some together. And I feel like we've hit conditionals now, right? That was the main point we were doing. That was this section. So that was actually everything that we would need here before you can go and you can start practicing on the problems that I made here. So I have 3 problems here. And like I mentioned, Python does not have a switch statement. You don't have to worry about that too much right now, but it's just interesting information because many other languages do. And switch statements are like if, else, if, else, if, else, if, else. Very similar. They don't do anything different. They're just a slightly different way of representing it. Okay, so given all of this, I'm going to let you go ahead and take a stab at the problems. And what I'll do is I'll just sit here and I'll be working on my own stuff. And then if you get really stuck or you have questions of something that I've written is not clear in terms of what you're supposed to do, you can ask me. But otherwise, I'm going to try to leave you alone until you get these things working. So I would highly recommend if you get stuck that you set a breakpoint and you go try it in the debugger, right? And try to figure it out by stepping through the code, right? We have three problems here, and without loops. So hypothetically, I haven't taught you loops yet, even though we just did 3 examples or a couple examples with them. But these problems, you don't use loops for them. You're just going to be using functions and conditionals. So I think
I'm trying to open. I'm not really sure how I'm supposed to open this. Is that Teams?
So if you go on this website right here.
Yeah, I also have the app. So
Okay.
I'm trying to figure out how to find this thing on it.
It will probably be, I'm actually not sure since I'm the one who shared it with you. So like if I go to my account and I can go down to like this, my REPLs right here. This shows it. I'm not so sure what it's like when it's not one that you own, but perhaps it's this. The REPL here that I called is called Python stuff. That's what we're learning stuff in.
Okay, so it should be showing there and it's not. And I'm not sure why, because I thought
could you go to your email perhaps? And I know, although you said you never got an email, right?
Yeah, I didn't. And I saw it the last time we talked. It was there. Like, I mean, I saw it on Replit the last time we talked, but I can't see it now.
So it says you right there. Says that you can edit it.
So why is it doing this now? Yeah, I've had this problem before. I'm not really sure what happened.
Are you logged in? Are you logged in as yourself?
Yes. No, I've seen it in my notifications. So let me see if it brings me there. Yes. So it wasn't my notifications, but it wasn't in my repos.
Perhaps because it's not yours, it's mine shared with you.
Okay.
Now, there might be a way, like I said, I've actually not so sure because this is mine. Now I'm the one who made it. So obviously it shows up in a certain way for me. You might be able to add it to yours. Like, I don't know.
Let me see if I can.
Like if there's like an add to my REPLs but somewhere for you.
Okay.
Well, I don't really know what it looks like for you, but.
Well, it's showing, well, pretty much the same thing, except it's just the main pie. Yeah, I'm seeing the same screen.
So if you click on things in the sidebar, that will let you open and close it.
Yes.
Yeah. Well,
yes,
for now, you can just get to it through notifications. So first practice problem here. We have to write a function that takes in 3 integers, that has 3 arguments and returns the one that has the middle value. So if you were to input 3, 7, and 1, the function would return 3. You can call the function whatever you want, but it should have this behavior. Is anything unclear about what it is that I'm asking you to do?
No, nothing is.
Okay, so go ahead and give it a stab, and then once you think you've finished, come and tell me, and then we'll go look at it. And in the meantime, like I said, I'm going to be here, so if you get stuck, you can ask a question. But otherwise, I'm going to go ahead and be working on my own thing. So this is your practice.
Okay.
Are you coding someplace right now?
No, I'm actually right there. I'm thinking.
Okay. Oh, I was just thinking. Okay. Yeah, there's your cursor. Just seeing where you were. So one of the first things you can do is you can write the function header, right? That should contain the name of the function and the names of the 3 arguments that you're going to pass into it.
Okay.
I think you can do that even without knowing exactly what else to do, right?
Yes.
So do you know why the program is highlighting that red? You have a guess? Because your logic is correct, but there's something about the way that you formatted the code that is not quite right.
Okay.
So are you familiar with how indentation in Python is super important in tracking like what is nested in what?
Yes, but is this elif statement supposed to be nested in the if?
No, but if you see what other thing is the elif statement in line with in terms of indentation level? Is that inside of the function?
Oh, right. I see.
Okay. And if you indented that, where should the return be then?
The return should be indented. Right. I wondered about that.
Should it be read? Now, how about the else?
Okay. Yeah.
Okay. Think you're done?
Yeah, I do.
Okay, I think you're done too. So there are actually multiple ways to approach this problem. What you did is you picked the number approach. So you said the first thing I'm going to do is I'm going to check num1, right? And then if num1 is in the middle, then I'm going to return it. And then the second thing I'm going to do is I'm going to check num2, right? And then by process of elimination, if it's not 1 or 2, then it has to be 3, right? This is a pretty clean way to do it. This is actually probably how I do it. The other way you could do it, let me do it real fast, just so you see. You can actually also use Booleans here. So 2, 3. I don't confuse myself in trying to show this. So we could do something like well, you know what, actually, so as not to confuse you, let's just keep it the way. There are other ways to do this, but this is a good way. Like I said, this is probably how I do it. Okay, so now let's go ahead and let's call your function. Let's call your function with the numbers that we said. Okay, so we're going to pass in number 1, number 2, number 3, which we defined above as 3, 5, and 7 respectively. And let's set the return value here of this equal to middle num is going to be equal to the return value of that. And then let's set one more. Just set something right below it, and then we can set a breakpoint here. Okay. So in what we execute here, given that number 1 is 3, number 2 is 5, and number 3 is 7, which case do we expect? Which of these 3 returns do we expect to get hit?
Number 2. That's
number 2. So we think it should be this return, right? Which would mean that we don't jump into this if statement and we don't hit the else. All right, well, let's see. Let's see if we're right. That's what I think should happen too. We go in the debugger, and then we run in the debugger here. We have a breakpoint set in line 260, which means we should jump into the function. We should have these variables defined in local scope, but we won't have done anything yet, right? Okay, so we jump in, numbers 1, 2, and 3 are defined in local scope. So this first condition checks, is number 1 greater than number 2? So number 1 is 3, and number 2 is 5. That means that this is false, right? And number 1 is less than number 3. That's true, but false and true means false. So this whole thing evaluates to false. Now, to make it more readable, once we get done, you might want to put parentheses around this whole thing, because the thing is, the if statement is checking the combination of these 2 things, right? So num1 greater than num2, that will be a Boolean, and num1 less than num3, that will be a Boolean. But what you're really checking is if when you AND these 2 things together, whether that whole thing is true or false, right? So I would suggest using parentheses here to group so that it's more clear what the logic's doing. But at any rate, because num1 greater than num2 is false, we won't hit this case. And now we're on this one, right? So if that's false, then the next thing the compiler will do is it will try to check the next condition here. If num2 is greater than num1, so num2 is 5, that is greater than num1, and num2 is less than num3, 5 is less than 7, that's true. So true and true will also be true, which means that we will hit this case, right? So if we step, you'll see we skip the first one, but we do hit this case, and then we hop inside, which is exactly what we expected to have happen, right? And so when we return 2 here, that means that the value of middle num here, we should end up back on that line, having called that function. And when we step over this, this is why I set another function. So if I continue to the breakpoint right after it, middle num here is going to be 5, right? Okay, now let's switch the order of things around, right? So we have numbers 1, 2, and 3, and those are entered positionally here. But now let's make, well, first off, let me hop out of debugging here so that we can edit things again and stop. And so we decided that it would make things clearer if we wrap things like that, right? Because what we're checking is the whole thing. Stylistically, probably no spaces is fine. Okay, so that's that change. But now let's make number 1 5. Okay, which case should we hit now?
We should hit 1.
We should hit this one, right?
Yes.
Okay, so I'm going to go faster this time. So we should hit the breakpoint, and then when we step, we should hop into there. And now that we're in there, now we're going to hit the next one, right? So we return middle num should still be 5, right? That doesn't change, but we hit this return point. All right, now let's switch it around yet again. And this time, let's make number 3, 5. Now this time we should check both this one and this one before we realize,
Yes.
oh, it's the third one, right? So let's see if that actually does happen, right? So we hit the breakpoint, we're going to step this one. Okay, we don't do that. We don't do that. That means we end up in the else, right?
Yes.
And we continue, and it's still 5, right? So that means we've tested all paths in our code, and all of them do the right thing. All right, so that was the first function. Congratulations, you got it right. All right, well, I'm going to cut us off there for today. We have to go to Bible study pretty soon here. But this is an introduction to kind of writing your own functions. And you are welcome to try the other two on your own time. If you do, it might mean that we can just go faster when we next meet, or you can do them the next time we meet as well. Both of these other things here. All right, so that's where we'll stop for today. We went through some examples here when we were talking about the idea of using Boolean variables when you're doing a complicated check inside of a conditional to make it more readable. And then we actually went out and scaffolded those functions that we would be setting here, checking some things about strings. And then after that, you started here on the practice problems, and we have 2 more here before we'll actually formally go on. We already kind of talked about debugging today too. I'll mention a couple other things, and then we'll do loops more formally, which, well, we already saw some of those today, but we'll cover those more specifically. And then there's even more practice problems down here as well. So plenty more to continue with, but we made some good progress today. So with that, we'll pick up next time.